It feels good to be a part of an industry that's done some good in the world even as we engage in commercial endeavors, we're able to deliver benefit as well. Our next speaker is going to talk about how governments can be involved in shaping the policy and hopefully directing it towards doing a lot of societal benefit, even as it makes a financially rewarding economic environment for the businesses. Next up, our next speaker is Bob Pepper. He's Vice President of Global Technology Policy at Cisco. But before he was at Cisco, he has a pretty illustrious career as well as a policy analyst in the FCC, talking about spectrum policies, auction policies, and a bunch of other things that really are important and fundamental towards shaping the industry. So with that, I'd like to invite up Bob Pepper.
Thanks. So, given the theme of capacity, capability, and collaboration, what I'm going to do, I'll talk about the policy piece of this sort of at the end, but what I'm going to do is talk about what kind of networks do we need to provide the capability for collaboration, cloud services. I actually have been playing with the presentation given the conversations and presentations and keynotes and discussions and panels and roundtables over the last week, which I think have been absolutely fantastic. So I'm going to talk about trends in global broadband demand, and you will have seen some of this, but there's some new stuff as well. Then I want to talk about what I call networks fit for purpose. What are the networks that we need, and what are the network capabilities to have collaboration? And a lot of that is the cloud-based. And what kinds of networks do we need for cloud services? And that becomes a really important variable. And then what are some of the policies that we're seeing? So many of you, I would hope, most of you, have seen and even played with our Visual Networking Index data, which is our 5-year rolling forecast of data over global, mobile, and then also our cloud studies. And just to put things in context, our 2012 forecast, which forecasts out to 2016, forecasts that by 2016 in the global internet, the run rate will be about 1.3 zettabytes per year. To put that in perspective, if you add up all of the data traffic for the history of the internet through this year, or through last year, that was only about 1.2 zettabytes. And what we're forecasting is that in 2016, in that 1 year, there'll be more traffic across the global internet in 2016 than in the entire history of the internet from its beginning through 2012. In terms of the average internet user, what does that mean? What we saw, actually looking at this, was for the average user consuming about 11.5 gigabytes per month. We're forecasting by 2016 32 gigabytes, by the way, and then off in the future 75. This is per user. In Japan, in 2016, we're forecasting approximately 46 gigabytes. For the average household, what we saw was about 26 gigabytes in 2011, forecasting 84. In Japan, we're forecasting 96. And the gap, by the way, between Japan and Korea, the two leading, we're here in the Pacific Telecommunications Council meeting, so focusing a little bit on the region. Japan and Korea have the two most broadband networks on average in the world. And you take a look at the gap between what's in Japan and Korea today versus the rest of the world. The averages, it's quite wide. But based upon what Tim was talking about, we're seeing that narrow as we see more fiber everywhere. Now, the question I always ask in terms of these forecasts, that's nice. Cisco likes big numbers. You sell more boxes with blinking lights, more routers and switches. Well, we actually go back and we actually look at the data, right? How reliable are the data? Well, it turns out, because we've been doing this long enough, we can go back and look at a forecast and look what actually happened. We're within about 10% on the conservative side. So what we've seen is that actually we're more conservative than what the market has actually driven in terms of data consumption. And this is very consistent with the telegeography data that Tim showed. What's driving it? Video. is the short answer. And what we're forecasting is that by 2016, more than half of the traffic is going to be video. But video doesn't mean just traditional television. It's all forms of video. So it's linear, it's YouTube, short form, it's telepresence, super high definition video collaboration, it's Skype video, it's FaceTime on your iPhone and iPad. But it's video in all of its aspects. But it's not just, the fact that, there really are 4 drivers for this increasing demand. There are more people who are going to be connected. There are more devices that are going to be connected. And those devices are going to be more robust. Third, there are going to be more applications that are media rich. And fourth, the network capabilities are going to interact with the other first 3 variables, and this is going to drive this really dramatic growth in data consumption. In terms of devices, we're forecasting, and this is not including all of the Internet of Things sensors and sensor networks. These are really more so the devices that people use or are involved with, and these could be devices in your car. But we're looking at, by 2016, forecasting approximately 20 billion network connections, and this is how they're distributed across the world. And what you see is that by 2016, half of the devices connected to the global internet we are forecasting will be in this region, the Asia-Pacific region. And so we're seeing a major shift historically, and again, I love Tim's data, and by the way, the telegeography map that they have looks at this also over time, that there's a shift in terms of internet connections, people, users, and traffic from what had historically been North America and Europe to emerging countries in the South and across the Asia-Pacific region. The types of devices that are being connected are changing. It used to be desktops and now laptops. And this, by the way, is not number of devices. The slide that you see is the amount of traffic that is being generated across the global nets coming from different types of devices. And what you see is that in 2011, 56%, 58% of the traffic was coming from laptops and netbooks. And about a quarter, 26, 27% coming from smartphones. What we're forecasting is that by 2016, that's going to flip. That smartphones will generate about half of all of the traffic across the global net. Now, what that doesn't take into account, because the forecast was at 2012, and we look back at real data in 2011 and forecast to 2016, tablets, and how tablets and the category between tablets and smartphones is blurring with the 7-inch, 8-inch tablet. Is that a phone or a tablet, right? So, and this is a dynamic model, and so I'm going to be really interested to see how that affects things. But we're seeing a very significant shift from the traditional form factors of laptops to smartphones and tablets, and these are the devices people are using to connect to the internet and consume the data and the applications, which is primarily going to be video-based. Let's talk about cloud. We have a new study that's now only 2 years old, based upon the same data and models, which we call our Global Cloud Index. And we look at cloud, we look at cloud applications, data center, the traffic within data center, between data center, and then to users of data center and cloud services. And we then take a look at networks and network capabilities, and using speed test data from a variety of sources, a sample of over 45 million tests from over 150 countries. And what we see in terms of the amount of data, and we're talking about terabytes and multiple zettabytes of data We're looking at, and what we're seeing is that about 3/4 of the traffic is within data center, 7% data center to data center, and about 17% of data center traffic is to the user. It's back and forth to the users. And then you look at traditional data center and cloud, and what we see is the shift between traditional data center applications and uses in the enterprise and looking at how cloud services based in data center are now going to be 2/3 of the traffic in and out of data center. And these are all of the cloud services that we were hearing about this week. And you look at the compounded annual growth rate of cloud services, the personal content, Amazon Cloud, Google Cloud, Microsoft Cloud, et cetera. Look at, Dropbox, Google Drive, Apple's iCloud. And we're looking at globally over 100% compounded annual growth rate and a 42-fold increase in cloud traffic between 2011 and 2016. And then you couple that with what we're seeing, and this makes complete sense if you realize that most of the applications people are using are video, and most of that video is residing in the cloud. Even on mobile networks, we see that a shift where we're forecasting that cloud will account for 71% of mobile data by 2016, and that has huge implications for mobile operators, the wireless networks. And one of the trends that we see is because of that, plus the investments needed, plus the way spectrum is allocated, is we see a trend towards the heterogeneous network. The majority of people will be connected to the net, to their broadband, using macro cell for outdoor, small cell, femto, but mostly Wi-Fi indoor, and for short-range outdoor. And it all has to be aggregated into fiber. T1s, E1s doesn't cut it. If you think about the backhaul needed from your wireless base station, whether it's your Wi-Fi base station at home or office or here in the hotel, and we know the constraints here, right? Or the base station, which is the antenna on top of the cell tower, if we're going to be able to support the bandwidth needed to provide the applications, it's all going to have to aggregate into fiber. So the future is the heterogeneous network. Macro cell, small cell, fiber aggregation. And 3 years ago, 4 years ago, when I would say that, or I'd be having conversations with service providers, many of the people in this room, the answer was, you're crazy. Wi-Fi is a toy. Wi-Fi is not secure. Wi-Fi, right? It's a competitor. And as you all know, that has been turned on its head. Virtually every wireless operator, and I consciously say wireless operator, not just mobile operator, in the world is looking at small cell to complement macro cell. And you even have cable operators in the US and elsewhere looking at Wi-Fi outdoors, hanging on their cables for small cell Wi-Fi connections to the device. Those 19 billion devices are going to be connected not with Ethernet, but with radio. So what kinds of networks do we need for cloud? Well, in doing our cloud study, we had to ask a very fundamental question. What do we mean by cloud services? And so we've come up with a framework, very simple, maybe oversimplified, for basic cloud, intermediate cloud, and advanced cloud services. And then we took, and I'll define some of these with some examples. And then we took a look at what kind of network is needed to support a single basic, intermediate, and advanced cloud application. And when we look at advanced, so basic doesn't require much. It's 750 kilobits down, 250 kilobits up. And by the way, in some parts of the world and this region, you can't even do that. Latency is not a big deal. You can deal with 160 millisecond delay or greater. For intermediate cloud, it's going to require roughly 1 meg to 2.5 meg down, 250K up, a meg up, and latency between 100 milliseconds to 160 milliseconds. Advanced cloud applications are going to require higher speed down, more than 2.5 meg down, at least a meg up, but latency of less than 100 milliseconds. And this becomes really important. But most advanced cloud applications are not single applications. They are multiple applications. Even something like a WebEx meeting or a net meeting, right? There's video, there's sharing of files, there's voice, there's multiple things going on. And so actually we've looked at cloud readiness with concurrent applications. The latency variable doesn't shift, but the bandwidth requirements do. And if you really want to be providing advanced cloud services, so let's take a look at what that might mean, including things like high-definition industrial design and collaboration, right? Because we're talking about the benefits of broadband and IT and ICT that increase productivity. And we're looking at, this is not just about people downloading movies and watching YouTube movies or uploading YouTube movies, but it's also about collaboration, it's about design, industrial design, supply chain management, all kinds of productivity enhancing activities in the business world, in the healthcare world, medical applications, education, government services, and the like. Those are going to require advanced cloud applications. Latency matters. Just think about it in a very common sense way. If I'm sitting in a design lab in San Jose and I have a colleague who I'm working with in Singapore who's working with another colleague in our R&D center in Shanghai, and we're designing something together, and we're doing schematics, or we're designing, if it's industrial design, an aircraft engine, and we're working in real time, it has to be real time. If I'm making a change and you make a change and they somehow, because of the latency in the network, cross in cyberspace, it's not going to work. It has to be as though we're working together on the same machine. And to do that, you need latency of less than 100 milliseconds. Those are the applications that are going to make a difference going forward. These are the kinds of networks that we're going to need to support that and support those kinds of intermediate and advanced applications. And the intermediate concurrent applications are going to require 7 meg down, 2.5 up, right? And the advanced applications over 20 meg down and 9 meg up in less than 100 milliseconds. So let's look at countries in this region. And what you can see here is that in orange are the countries in this region, the Pacific Rim countries. And you can see the average upload speed on the vertical axis and the average download on the x-axis and the plots, and you can see where countries are. And then let's take a look if we add, this is the fixed networks, let's add latency. And what you can see is that on the fixed networks, there are many countries in this region that actually can support at least some advanced cloud applications concurrently, individually, yes. But so, and if you take a look at the countries that have high bandwidth, upload, download, and low latency, it shouldn't be a surprise: Singapore, Japan, Korea, Hong Kong. But there's a whole bunch of smaller countries down here that on their fixed networks cannot even support intermediate cloud services. This is fixed. Now let's take a look at mobile. Again, here are the countries globally, Pacific Rim countries in orange. And you can take a look and you can see the plot of download, upload. Now let's add latency. Only 3 countries in the region, not surprisingly, Hong Kong, Japan, and Singapore, can support mobile, wireless, supported advanced cloud services. The biggest variable is not bandwidth. The biggest variable is not the capacity of download, upload. The biggest variable is latency. And on the wireless networks, the heterogeneous network, what this means is that until we have LTE, 4G, we're not going to bring the latency down. And we're not going to be able to support those kinds of advanced cloud applications for collaboration. So, what kind of network do we need, and what are some of the policies? And I'm only going to very briefly just highlight this with 2 very quick slides. There's a study that we're doing looking at national broadband plans globally, and we've come up with a framework that looks at both supply side and demand side. And our conclusion in looking at all of these broadband plans globally, and we're doing this in conjunction with the World Economic Forum, and they'll be published in April in the Global Information Technology Report. And we're also working with the UN Broadband Commission on this, that you need a balance of supply and demand to nationally drive the economic as well as policy and technical ecosystems to get the kinds of networks that you're going to need to support these advanced applications. So in conclusion, what are the networks that we need fit for purpose? Number 1, we see that there are going to be more people, more connections, more devices, and that's leading to exploding demand. Second, most devices are going to be connected with radio. They're going to be wireless. They're not going to be Ethernet connected. That's the heterogeneous network. So we need to think about spectrum. We need to think about the types of spectrum and the types of networks. And what that is leading me to, again, is the need for spectrum, more spectrum for macro cell LTE 4G, and more spectrum for unlicensed Wi-Fi indoors. 802.11.AC and so on. Third, demand is driving applications in the cloud, and a lot of that is video. It's cloud services in business as well, and it's the advanced cloud applications. And advanced cloud applications need high speed, symmetric, and low latency. The question for companies and countries and policy, is your network ready and fit for cloud and collaboration? Good question. Thank you very much.